Welcome back to Unit 13 in Animal Science, and this unit is going to focus on swine production, and chapters 28 and 29 in your textbook, and the recommended reading is listed there, which I'm sure you've already read. Let's get to the content and talk about swine. Swine breeds' characteristics are generally grouped by hair color and whether they have drooping or erect ears, and we've seen a lot of change in popularity of breeds with time and technology and hybridization or hybrid vigor or crossbreeding beginning in about the 1940s, really selected with the objective of measurements. Here's a figure provided by your textbook that shows a lot of the major breeds in the U.S. with the Berkshire at the top and the Yorkshire all the way at the bottom and everything in between. That's somewhat prominent here in the United States. Sow productivity, let's get to some traits and their measurement. And if we look at sows, I've highlighted or bolded a few things here in terms of litter size is extremely important and highly genetically correlated. The number of pigs weaned per litter, the weight of that litter at 21 days, the number of litters that sow may have in a year. Some of these traits are not very highly heritable, so we have to really focus on our management to select and get these traits to come through, manage it through feeding and health. And obviously we've seen some gains through crossbreeding help some of this productivity. Another picture supplied by your textbook with pigs raised per sow at a litter of 21 days of age. Notice a lot of quite a bit of uniformity here in this situation. A change also a little bit away from the more narrow or farrowing crate or farrowing stall with a little bit more room for that particular sow to lay there and nurse pig. Growth rate is about 35% heritable, so on the high end of medium. So we can pretty effectively select for this, but we're going to measure growth rates by the number of days it takes to reach 260 pounds body weight. Feed efficiency is one thing that, at least in my opinion, that the swine business has picked up on the earliest and taken the farthest in terms of researching it and figuring out how to magnify it on their operations. They're really looking at how efficient we can make our pigs gain with feed per pound of gain. About 30% heritable here. Absolutely crucial because feed accounts for 60 to 70% of the cost of production. And again, so how can we monitor that? The nice thing is we have pretty automated feeding systems and a pretty consistent number of pigs per pen. So we can have a really good idea of feed efficiency in a hog barn. Can't be done though without measuring body weight, and here's a nice scale system that really can quickly and accurately and electronically run body weights, and so we can pull pigs out of pens and run them across the scale quickly and monitor and collect data with speed in a speedy and accurate way. This is an older picture that I kept in the slide set because I like the example here that this guy is measuring back fat thickness on a pig pretty quickly. You can get him into the little chute there and run the ultrasound just like they might use on a pregnant lady at the hospital. Very similar apparatus, but good way for them to measure back fat thickness and start to make adjustments before that pig might go to slaughter and see it. Carcass traits, we use this to estimate the pounds or percent of acceptable quality lean pork, which would be about 10% fat in the carcass. And look at this number, 48% heritable. So frankly, this is one of the easiest traits to select for, and there's three things that we use to predict this. The amount of fat over the loin at the 10th rib, which would be basically what you saw in the previous slide, that gentleman measuring loin, eye, muscle area, and the carcass muscling score. Again, we can predict it in live pigs with that ultrasound like you saw in the photo, or there's some pretty good trained eyes out there. Pretty good idea. Next, in terms of traits and their measurement, is we can look at structural soundness. And basically this is the capability of that breeding or slaughtered animal to withstand the rigors of confinement and or breeding. And this is a somewhat heritable, and I don't have a number listed on the slide, but it falls in the about 25 to 30% heritable range. And when we talk about pigs that we identify as unsound, whether they have leg problems or something like that, it's just best to get them out of the barn and get them cold, because generally those pigs do not perform, and we spend a lot of time trying to nurse them along, and a lot of money and a lot of extra effort, and they really oftentimes never keep up. So unsound pigs generally get cold pretty quickly. Of course, there's some inherited defects that are problems out there, just like we've identified in all the other species throughout the course here, with inverted nipples going on that list. PSE, pork, or pale soft exudative meat, which is just basically soft and slimy type pork. Porcine stress syndrome. There's lots of things that happen in pigs as well, just like all the other that we've talked about. So if we take and effectively use performance vectors here, obviously we have two influential factors. We have genetics in play, and we have the environment in play. So four kind of keys that your book supplies to us is what we think is a good sound genetic improvement program. Number one, accurate and complete performance records and animal identification. If you don't know which animals are doing what, and you haven't recorded good records in the first place, it's pretty tough to assess what's going on your farm. Number two, assessment of genetic merit of important traits. Identifying those key traits on your operation, and then assigning some economic indice to that. Relating traits of economic importance to commercial pork production. So when we talk about commercially hanging that carcass on the hook, what relates all the way back to economic importance there genetically. And then selecting the highest ranked boars and the highest ranked gilts based upon the data that we have. You got to take that data and now apply it in your genetic selection. Really, the rate of genetic improvement is parallel on commercial farms and seed stock producers. I've got a chart that I hope will back this up here in a little bit. There's a lot of different genetic evaluation program, and here's an example of one, and we won't spend a lot of time, and I don't have a lot of questions attached to these, but if you're interested in some of these swine folks out there, might be good to dig into a few of them, but a few questions here to kind of check and track genetic improvement. And here you see the EPDs, expected progeny differences. I mentioned referenced earlier in terms of what might happen, theoretical genetic change, and this is an old chart that I kept around because I like how it portrays it. And you kind of can't see the first line down there. That would be series 4. Is basically a flat line on genetic value. Basically, we'll start there and think, those lines, genetic trend of commercial herds that don't use any improved breeding stock and really no selection pressure. And by selection pressure, that means we're not trying to improve anything. We're just kind of breeding hogs without much goal in mind. So notice over time that you're seeing basically no genetic improvement. Let's step up to the white line with the triangles on it. There's a genetic trend of commercial herds buying average breeding stock from superior seed stock herds. So notice now we make a almost linear improvement on your genetics over time in terms of genetic value. Series 2 then is the gray line with the boxes on it, and you have genetic trend of commercial herds buying superior breeding stock from superior seed stock herds. So, for example, these commercial herds might be buying seed stock, breeding stock from the black series right above it. And so you see that parallel line, their genetics are very, very closely following what's going on in the seed stock or purebred herds, so to speak. And then leading the way up at the top there with the highest linear improvement is the black line with the diamonds, the seed stock herds using all the available selection tools, making the most genetic progress. I contrast this because I think this is fascinating that the swine industry has data that supports how closely tied their purebred animals are to what their commercial animals are. Because I would challenge those of us who are either in the beef industry or the dairy industry or the equine industry, which there isn't as much commercial aspect to it, are our genetics in the seed stock and the commercial side as closely matched. And I think there's more divergence there in preference. So interesting concept to talk about. Just like we've hit in the other two species prior, let's talk about selecting replacement females that are going to go in the breeding herd, which is super important in commercial pork production. We want to select the fastest growing, sound, moderately lean, good body capacity gilts that are from litters in which there was 8 to 14 excellent pigs weaned. You say, well, what is important about that 8 to 14 number? If they were weaned out of a litter of 6, then they're probably not going to genetically also wean a large litter of pigs. So you want to put that on your list of things that's quite important. Sows that farrow and you're going to think about rebreeding them, always evaluate those sows that you're going to attempt to keep in the breeding herd, and then cull some if you see any physical problems, dispositional issues, smaller litters, and I'm talking 2 pigs below the herd average. So if your herd average litter is 12 and that pig had a 10 pig litter, you might be thinking about putting that sow on the wean list or on the cull list, or sows with poor mothering records. But bottom line, we've got to have enough gilts identified to replace culled sows that we're going to put on the semi and send them down the road. The suggested replacement rate is about 20 to 25% each time. So, and I asked the question here: what happens if your cull rate is higher or lower than that? Let's say we're culling it only 10%. That means we're saving a lot of sows and keeping them in the herd. That might indicate some really good things going on. You have great genetics and you don't necessarily need to replace a lot of sows. The struggle with that might be is genetic progress may slow down as you lower your cull rate. Contrast that with, let's say we went to 35% cull rate. So we were culling a lot of sows out of the herd on a regular basis. The good part about that is you're going to introduce a lot of new genetics in a hurry because you're going to have to replace those sows with new gilts. The problem with that might be is potentially we have some issues developing on our farm that we need to cull that many. So there's a sweet spot in there that each farm needs to identify what is your ideal cull rate, because you certainly need to be changing out your breeding herd somewhat on a basis. Things that contribute to sow culling rate are age, all the way down to poor litter size or survival rates, and a lot of things. Here's just a chart that your textbook supplies in terms of 5 different levels of muscularity and leanness in market hogs. We'll kind of apply that as we go through here, and you can reference back. I thought it was nice to throw in here what we might be looking for. So, continuing our discussion on identifying replacement pigs here and keeping those pictures in mind, is at birth we're going to identify all the gilts and disqualify all members of the litter if there's any member of the litter that has a defect. So if one baby pig in the litter has a inverted nipple, we're going to disqualify all the gilts from that herd in terms of potential breeders. The reason, they could all be carrying that genetic defect. At 3 to 5 weeks of age, we're going to take a 21-day litter weight. We're going to wean them, and we're going to reject gilts with less than 12 teats. And so we want to identify at this point in time, we want to have 2 to 3 times more gilts than we need for replacement of our cull rate. So if we're going to replace 20%, we need to have 60% basically identified at this point in time. By the time those gilts reach 180 to 200 pounds, we're going to weigh them, ultrasound for back fat and check soundness. And we're going to pick the fastest growing, leanest gilts from the largest litters. And here we need about a third more. We're going to identify about a third more pigs, gilts than what we actually might use. At breeding time, then, we're going to just keep enough gilts to offset your non-conception rate. So if your non-conception rate's 5%, we're just going to keep 25 to 30%, let's say, in order to offset that amount. Some benchmark goals here, and this is stuff that comes out of your textbook, and I would encourage you to think about each farm is completely on its own to develop their own numbers, but just some numbers at least for us to throw out and talk about. Litter size, hopefully we have more than 10 farrowed, and hopefully you have more than 8 weaned. And if you want to adjust that number up or down, that's certainly your prerogative. The underlying, hopefully we do have 12 fully developed, well-spaced teats. Feet and legs, wide stance, free movement, good equal-sized toes. Hopefully we can reach 230 pounds in less than 155 days with a 240 feed per hundredweight of game. That would be a 2.4 feed conversion or feed efficiency. So average daily gain should be about 2 pounds a day. Back fat ultrasound thickness 0.8 of an inch or less. Selecting boars, and again, critically important, 80 to 90% of the herd genetic composition over time is related to boars. And so you're going to select boars that have dams that are very, very highly productive sows. And effectively, we're going to determine the boar's ability to pass on those traits to replacement gilts is what our goal is. And boars and replacement gilts for quite some time are going to be raised basically the same as all your market hogs, because we want to see what genetic capability they have in a commercial setting before we separate them off as into your breeding herd. Crossbreeding is really very, very advanced in the swine business, using 2 or more breeds, increasing that hybrid vigor quite a lot. So more than 90% of your marketed hogs in commercial production are crossbred. And there's basically 2 types of crossbreeding: the rotational systems, whether it's 2 or 3 breed, or the rotational system with a terminal cross sire. We've pretty well talked about these already. I added the slides in here again just to reinforce an important point. But these are absolutely crucial, and anytime you add a terminal cross boar in there, all the offspring out of the terminal cross boar are going to go to market. That terminal cross sire is carcass selected only. This is a process flow chart for creating improved genetics in the swine business and for commercial hog business, and I'll let you kind of go through this on your own time. I found it kind of fascinating how they really stepped through the process on where they were going to pick their genetics from and how they would go about outcrossing or outsourcing some other boars and other genetics to bring into their operation. So pretty interesting slide that provides. Let's pivot and talk about the types of swine operations. And we have seen clearly an evolution of the entire industry here over time, and some of this would be a little bit more historical and some of this would be a little bit more modern. Like the probably most likely modern type pig operation is a farrow to finish setup, that they farrow out all their own, they have all their own breeding stock, they farrow out all their own pigs, and they have all their own finishing facilities. More historically, you had feeder pig production, which would be your breeding herd and farrowing houses, and then they would make those feeder pigs for sale at about 40 pounds body weight, whether it would be direct to a finishing operation or at the sale barn. And those then, like what's listed at number 2, you would have a finishing pig operations that would take those feeders and feed them out to slaughter. I would contend that there's very, very few of those standalone type operations today. Now, certainly there are producers that all they do is finish pigs, but they're many times tied to a larger conglomerate, and I reference specifically the model that the Mashoffs had, where the Mashoffs management system and company is a farrow to finish operator. They have their own barns for farrowing out baby pigs, and then they transfer those feeder pigs to finishing operators for them. So that would be an example of a more modern business model in the swine business. And then you do have still the purebred or seed stock genetics producers out there that their sole focus is really improving the genetic profile of the swine industry. Farrow to finish, is big time swine production. We talk about boar management when we talk these farrow to finish operations that are breeding quite a bit. When you bring in a boar, you want to purchase them at least 60 days prior to breeding season for acclimation. That acclimation is important for allowing them to be exposed to any pathogens that are on your operation. So simply walking them through the barn will be important. They should be quarantined for the first 30 days of that 60, so they don't spread any pathogens they have, and then fence line exposure the second 30 days. You're going to feed those young boars about 6 to 8 pounds of feed until they reach about 260 pounds body weight. Servicing boars need about 3 to 6 pounds of feed per day. 1 in 12 boars, so just under 10%, are infertile. So make sure you test mate or pull a semen sample on all these boars and make sure they are in fact fertile. Young boars, if you're letting them pen breed, they're going to cover about 8 to 10 gilts in 4 weeks. Mature boars, a little bit more than that. And if you hand mate them, then you can increase the number that a boar can breed in a week's time. The females, the gilts should start cycling about 5 months of age, and it's pretty common to not breed them the first cycle. And the reason is we call that a flush cycle. Allow them to go ahead and ovulate and move a set of eggs off of the ovaries with the theory that the next time that they ovulate, they will ovulate more eggs and your litter size potential would go up. So hopefully breeding gilts, your target at 8 months of age would be about 250 to 260 pounds body weight, keeping about 10 in a pen. And again, make sure that temperature, herd health, all those, if we have any issues there, it's negatively going to affect your conception. Here's a nice example of bred gilts, a diet that allows them to reach specific target weights, and notice how clean it is, bright, it's well ventilated, and you see really kind of across the pen you see pretty consistent sizes, frame size, consistent body condition. AI is about half of all market hogs, and again, nutrition is always a critical component. We need about 4 to 5 pounds generally per day of a really balanced ration under normal conditions. Gestating pigs should be fed to gain about 75 to 120 pounds. So if you've got a replacement gilt coming along, first time having babies, she needs to gain probably 120 pounds on the high end here. If you've got a sow that's multi-litters through her, she basically is only going to gain about the weight of the litter, maybe just a smidgen more. So she should be down in that the low end of this range. Again, sow management here. Hopefully during farrowing and lactation, I give you some targets that we listed already earlier. Deworm them, and you say, well, what's the need to deworm if we're in confinement? There probably isn't that many pathogens there or worms to be worried about. That's false. You should be continuing to deworm pigs out there and make sure that you're avoiding any worming issues, because they can share those with the litter of pigs that are there in the, along her. Clean the sow. Make sure that you disinfect the area. Ideally, you'd want to leave that farrowing pen unused for 5 to 7 days once you have it cleaned. That way, no pathogens can take over again and pass from one to the other. But gestation, again, 3 months, 3 weeks, 3 days. So about 110 days is what that adds up to. Feed intake, here's a guideline for lactating sows, and I'll let you consider what the book has to offer in terms of it. Here's again a good picture of sows and litter pigs in a farrowing crate. You see the heat lamp over the top of them, keep them nice and warm. A farrowing barn or farrowing pen is going to have to be heated to about 90-95 degrees. Those baby pigs don't have a lot to keep them warm, and they struggle early on to develop enough body heat. Can't consume enough milk fast enough in order to keep body heat. So when we have sows that nurse fewer than 8 pigs, we're going to drop them down about 3 pounds of feed for maintenance, and then about 1 pound of feed for every pig that they're nursing. Any sow or gilt that's nursing more than 8 pigs, they can pretty well be fed for free choice. Now, talking to folks who are in farrowing barns, probably the most common method of feeding is pretty well free choice. It's much simpler and more consistent. Occasionally we'll see induced farrowing, and part of that is for labor efficiency. Part of that is reducing pig mortality. Sometimes we need some cross-fostering going along here, but just a management technique in order to maybe having pigs be born whenever there are more likely to be people around. The farrowing crates, there's been a lot of heartburn over how farrowing crates were designed and maybe should be designed, but the idea and the concept of the farrowing crate and why it is so restrictive is a third of baby pig deaths occur within the first 72 hours because they're crushed as the mother sow lays down, and she does not intend on laying on those baby pigs. It just happens. So that's why they were engineered that way in the first place. We've begun to open up and make those farrowing crates a bit larger, just as a response to change from clientele. Hopefully assisted birthing is not needed unless there's really obvious problems going on. So here's some reasons for pre-weaning pig mortality, and notice of all the causes of pig deaths, over half of them still are just crushing, and this is 2006 data coming along. 14% due to lactation failure or rump pigs that starved to death. There's a 10% that's known problems that goes in a variety, about 10% again for scours, just 5% for respiratory. We've done a great job now of figuring out how to properly ventilate our barns. That number has come way down over the years. And then about 8% that we don't know why we baby pigs. Difficult births, anytime we have some kind of dystocia, that can result in what we call a disease complex of MMA, or mastitis, metritis, and agalactia. Mastitis we've already talked about in the dairy section, and it is basically very similar to the mastitis problem in dairy cows. Metritis is an infection in the uterus area, so you can have a uterine infection there. And then agalactia is just simply no milk production out of one or more of the mammary glands. So obviously anytime you have that occurring, you have baby pigs that struggle then to get enough feed. Baby pigs should get colostrum within 4 to 6 hours of birth, and that colostrum content not only decreases, but baby pig's gut ability to absorb those big proteins decreases in 6 hours. I've mentioned air temperature is very. So here's some air temperature guidelines with relation to weight and age and where they should be. So very crucial chart here, and it shows the upper and lower critical temperatures for pigs in different sizes. Cut the navel cords and dip them in iodine. We've got to clip some needle teeth in order to prevent injury. Remember, pigs are somewhat vicious animals. They will attack and eat each other. That's part of the reason for clipping those needle teeth. They sense blood. They will go to eating it. Ear notching for identification, if that works in your operation. They need shots for anemia, so we've got to provide iron shots. Certainly work on preventing scours. That's absolutely critical because they can have real problems with that, and it can spread quickly through your barn. Castrate before 2 weeks if you're not wanting to keep a boar. Tail dock and continue with those iron boosters. And here's an example of an iron shot being given to a baby pig. They don't have the ability to make enough iron or consume it fast enough. So that's why you have to do a little bit of injectable early on until they can consume enough feed. Notice that he's injecting it up in the neck muscle, a less valuable meat, and not injecting it in the hand. Those should never be injected in the hand, the iron shot. Creep feeding is going to start in about 1 to 2 weeks of age, and because sow milk production generally peaks by about week 4, and creep rations are usually going to be high amounts of milk protein. They'll actually oftentimes pellet that and spray a milk protein or whey protein over the top of it. It makes it very palatable and consumable for the baby pig. There's a lot of different weaning guidelines, but basically match your weaning strategy to your management program. Generally, modern meat type pigs, they're going to average about 3 pounds of feed per pound to gain from 40 pounds to market, and really well balanced rations are that kind of efficiency. Almost all these diets from finishing diets are going to be based in corn. That's the cheapest one. You'll also find fairly commonly barley. There's a lot of wheat fed to baby pig in pig rations. The occasional bit of milo, and some byproducts. Distillers' grains have been added. A number of other things. Grinding is absolutely critical. We have to increase the particle size access. We have to increase the digestibility of that feed, so it's generally ground very, very, very fine for pigs to consume, and the finer it is, the more efficiently it's digested. Pelleting is an option because you can take that feed and send it through a pellet mill. You gain a little bit of advantage because of added heat and steam helps make it even more digestible yet, so we have about a 5 to 10% increase in that digestibility of the feed. Makes it a little bit easier to consume occasionally. The disadvantage, of course, is we're adding cost. The most economical protein source, and generally one of the best performing ones because it has a wide variety of amino acids, is soybean meal. So you see almost all the pig rations are based in corn and soybean meal, and then everything else is fit in around those two main ingredients. Always supplemented with minerals and vitamins, of course, and proper care of corn to prevent mycotoxins. So good quality corn is critical. And then the pig business was one of the first ones to really think about supplementing specific amino acids, and I asked which is the first limiting amino acid, and that's lysine. Pig diets add lysine, and that tends to increase feed efficiency, and they've led the way in some of that scientific that's been passed on to other species. Calcium and phosphorus are two of the most important macros, but I don't have listed here, so make a note on the side. The most important ingredient is salt for pigs. I need to get that added to my slide set here, but salt is the most important macro mineral for them. If you look at feed additives, and again this is changing a little bit with veterinary feeding directives, though I'm sure that the vets are working hand in hand with the pig feeding operations in order to feed antibiotics, chemotherapeutics, or dewormers throughout whenever it's appropriate. The idea in decreasing the number and the time that pigs are exposed to antibiotics is to hopefully decrease the opportunity to create disease or antibiotic resistant pathogens. There's some worry that resistance can be passed along to humans. I will say that there's not a lot of science that backs up that concern at this point in time. We are trying to decrease the amount of antibiotic load being offered to pigs and really all across all the species. And the amount of time that we do feed those kind of things, there is some effort to do that because of consumer concern and demand. But there's not a lot of science that backs up that because we're feeding antibiotics to our meat or milk animals that antibiotics aren't working in humans. There's a lot of research going on there, but I don't think that there is an absolute conclusion. Anytime I have at the bottom of the screen, be cautious of withdrawals. Anytime and in any species. And if I haven't enforced this enough already, anytime that you're feeding antibiotics, be cautious of withdrawal times. Generally, you're talking about 10-day to 30-day withdrawal times when you're feeding an antibiotic of any kind before that animal can go to slaughter, because they will be rejected if there's any antibiotic residue in meat, milk, or eggs. Here's a picture of weaned pigs in a modern nursery unit. Again, notice that it's very, very clean. There's plenty of space there, and they're all crossbred pigs. Look exactly the same. All pretty much the exact same size, with plenty of space for them to roam around. They're about 40 to 50 to 45 pounds. Here's a group of pigs in a growing and finishing production unit. Again, an enclosed building. Slatted floor, so all the manure drops through. One of the important engineering models in these slatted floor barns, and they relate it back to number of head in the each pen. There's a nice little relationship to the number of animals per pen. and the ability to push that manure through those slats into the pit beneath the barn. So, but again, notice pretty consistent size and body condition on all of those pigs in the pen. Guidelines for providing water, whether per nipple and the space between them, and how much they should consume. Thought this is a nice slide to add for you if you're looking and just curious about some things. There's some of that nipple design, and notice they're easily able to stick their mouth up there and drink from that water nippler. Hopefully the goal is not to waste any water. You don't want to add any more water to the pit than necessary. That just would be wasted expense. Feeder pigs, if you were purchasing them, they're subject to a lot more stress than farrow to finish operations, where they basically don't move very much. Anytime you move pigs on a trailer, that's a stressor to them. Anytime you change feed or environment, that's a stressor to them. Common reactions is outbreaks of respiratory type diseases. So management priorities, always make sure that you have a clean, comfortable environment, properly sized pens, a properly formulated starter diet, medicate it if needed, and work with your vet on that, and promptly treat pigs. In the past, pigs were marketed between 200 and 220 pounds body weight, and if they got over that, then we had a lot of extra fat to trim off of that. At one point, we had pigs marketed really a lot heavier than that as well. So the pendulum now has kind of settled into marketing hogs about 250, 260 pounds body weight. And the difference is we can put more lean pork on the same frame, or a little bit better carcass frame than what we were used to be able to do more efficiently. 80% of today's market hogs are sold on a contract basis. So the day that hog is born, she or he's probably already sold, so a price is already locked in. There's a couple different contract options here, but this allows a hog producer to know what they're going to get on the back end in terms of a market price, and gives them the opportunity now to buy feed and lock in an input price. And so hopefully they have a profitability window in there with which to operate. And a lot of those pigs, like we say, sold already direct to the packer before they're even born on a contract basis. Again, some performance benchmarks that I would say are important all the way through, and be ready to be able to check in on some of these if you were given an assessment, what typical farrowing rate should be, or mortality rates, and so on and so on. Average monthly return on farrow to finish enterprises, and this data goes back to 2004 in terms of dollars per head. And notice again the cyclical nature of this, and we had some pretty rough months and a pretty rough year in the 2009 to 10 range, and then 2013 was pretty rough, and we've seen a nice recovery here in the pig business recently. Farrow to finish operations, very tightly designed. You see generally very good ventilation controls, really good air movement in those facilities, really proper environmental stewardship in terms of manure handling, feed systems that are properly sized to get a batch of feed through there in an appropriate amount of time, and automated water. Here's some swine handling and transport guidelines. There's a lot of stuff on this slide. I'm not going to read any of it to you. Again, just something that I threw in for your reference and for you to kind of read on your own time. And speaking with guys like the Mashoffs, they dedicate a whole department to transportation logistics, and they monitor very closely what happens to those pigs on the trailer, what temperature, when they move them, how many pigs go on a semi at a time, and so on and so forth. There's very close monitoring and research goes on just on handling and transportation. Cost components, what makes up the feed to farrow finish budget, or farrow to finish operation budget. And again, we wrap up this section with some environmental management stuff. So a really good manure management plan, of course, avoids discharge, runoff, or seepage of manure into surface water conveyances, which would be creeks or streams or ponds or whatever. Hopefully we're releasing very little ammonia into the atmosphere. No detectable odor beyond the farm gate, which is sometimes difficult, I know, but try to keep that odor down. Obviously, try and not have any release of pathogens into the environment, and no contamination of groundwater, so no seepage through your lagoon and water tables. Things that help control odor on your operation. Finely ground grain can be very, very dusty and sometimes carry more odor. Vegetable oil, when you add vegetable oil or fat, that helps knock down some of that dust. Dust is what carries a lot of odor a lot of different places. So obviously pelleting comes into play and helps a little bit with that as well. A little bit of nutritional management. So the more exact that you get with feeding amino acids, actually the less total nitrogen that you will feed, and you can actually decrease then the amount of ammonia production in your barn. And again, we continually are working on decreasing the amount of phosphorus feeding, so we can decrease those discharges as well. Some take-home messages then on the swine unit as we begin to wrap this up over the last 40 minutes here. Again, crossbreeding, a huge part of the commercial pork production operation. Increases profitability and has done a great job of improving genetics. One of the keys is feed efficiency. They really look at this, and those of us in other species can really take some and learn some information off of the swine business here. Understand the importance and the critical nature of maintaining high herd health planes and disease prevention on your operations in the pig business. They are very keen on biosecurity and making sure, because in those operations that are confined, once a disease starts, it can run through a lot of the pigs in a hurry, and you can have huge morbidity and mortality rates. So preventing disease introduction into those barns is absolutely top priority. And then pay attention to environmental impacts both inside and outside the farm. Be a great environmental steward. So we've covered a lot of information here on the swine business. I look forward to chatting with you about it in class.